Last year, during this competition, I told you that the global population was predicted to reach 9 billion people by the year 2050. This year, I need to make a correction. The global population is now predicted to reach nearly 10 billion people by 2050. This number is daunting, but I believe that we can look toward the future with hope and not fear. Our population may be growing rapidly, but so is our knowledge and our ability to innovate towards sustainability. There are amazing innovations that allow us to use our resources more efficiently. Our lab works on the production of biofuels. Biofuels are an amazing alternative to fossil fuels because carbon dioxide released from burning biofuels is the same carbon dioxide recently taken up from the atmosphere by the plant. We already use biofuels as an additive to gasoline. Currently, biofuels are mainly produced from grains, such as corn. This is done because grains contain a lot of readily available sugars. But with billions of people relying on grains for food production, we can no longer afford to continue using grains to produce fuel. However, there is an amazing amount of sugars in the non-edible plant tissue. If we look at a plant, we see that it's mainly composed of a large molecule called cellulose. Cellulose is the main structural component of all plants and the most abundant plant-based material on Earth. When we look into a plant cell wall, we see that there are layers of cellulose that give the plant strength and structure. And if we look further into that cellulose molecule, we see that it's made up of long chains of glucose. Glucose is a simple sugar that can be converted into biofuel. Our main challenge lies in the structure of cellulose. Sugars and cellulose form a tightly packed crystalline structure. This is incredibly strong but very difficult to break down. Our lab works to make the conversion of cellulose to biofuel more efficient. We do this by causing small changes to the plant DNA that can affect the crystalline structure of cellulose. These changes are so minor that the plant is still able to grow and produce healthy grains. However, when we can change the structure of cellulose, we now find that we can access more of the usable sugars in the non-edible plant tissue. This will allow us to produce biofuels while maintaining grains for food production. Continued work on this project will allow us to meet the food demands of tomorrow while reducing our reliance on fossil fuels. Innovating towards sustainability will drive us into the future with determined minds, hopeful hearts, and engines powered with premium gasoline. Thank you very much.